Okay.
Alright, here today we have an expanding gate valve that I'm going to show you how to install the thermal relief bypass system on and talk a little bit about its functionality. And what it does is it drains from the mid-body cavity right here. When the gate is closed and the pressure is cut off on this side, because it's a unidirectional valve, the flow will be going this way every time. When the flow is cut off, it causes fluid to get trapped in the cavity, and if the pressure rises, or the temperature rises, it'll cause the pressure to rise, which can cause overpressuring. That's the purpose of the thermal relief bypass system. It's to allow the pressure in the mid-body cavity to drain out to the downstream side. And here I have all my fittings are already pre-Teflon taped just to save some time, and that creates a tighter seal, causes no leakage. And just gonna start putting these in where they go. These here are just nipple extensions that bring the thermal relief bypass system out far enough away from the valve, that way we can construct the rest of it. This here is a needle valve. Simply cuts off the pressure when we want to and allows for drainage in certain places. And then on this side, just another nipple extension followed by a needle valve. And then here we have a tubing extension. One side is threaded with male NPT to thread into the needle valve, and then the other end is set up to attach directly to the tubing here. And on this side we have a check valve that also, like this, is a unidirectional valve. It only allows the flow to go one way. It has an arrow on here indicating it, and we want the flow to come from here up and then down into this side, so we have to make sure that the arrow is pointing down so the flow goes this way. Followed by another tubing extension. And here we have our T-junction that fits right into this. And this is actually tubing connector on each side with an NPT midsection. That way we can attach another needle valve which will allow the thermal relief to be drained out after any fluid gets trapped in it.
So the needle valve's attached to one side?
Yes, a third needle valve is attached to one side, which allows drainage. And then here, if you see, these bevels here have already been tightened down, and that's what actually makes the seal between the tubing and these right here. It's not actually the threads that make the seal. These are pushed down on the inside to make an airtight seal.
Those are called the ferrules, correct?
Yes. Two-piece ferrules. There it goes. And of course, this would all need to be tightened down much tighter. for actual use. But once the flow was shut off, you would then open this needle valve, which would allow the flow to come up through here. This one would remain closed unless if you wanted to drain out into the atmosphere, as they say, which typically you would hose off and have it going into a bucket or some type of controlled draining atmosphere.
What makes the bottom drain valve obsolete?
This one?
Yeah.
Nothing. This is still used for draining. This is just used for draining out the thermal relief.
Oh, for draining out the actual little pipe
Yeah.
tubing system.
That and you don't always want to drain out from here, because then whatever you're piping is no longer in the piping system. If you drain it from here back into here, it's still within the pipe. This would be out into something else.
Into the atmosphere?
Yeah. And yeah, so with both these needle valves open, it'll allow the flow to go through there, and then should you need, you can drain out of there as well. And that should just about cover it for the thermal relief for today.